Hello, I'm Yaroslav from Lightnovo Customer Support, and in this video I'll demonstrate the capabilities of Lightnovo C SDK in Linux. So I have a miniRaman device which is attached to the computer with a USB cable and a polystyrene sample attached to the device. Reference polystyrene sample from Lightnovo. The purpose of this demo is basically to log the data from the device into CSV file using C program, performing the calls to the SDK, and to visualize the data. I'll show live visualization with gnuplot engine. Actually, you can check them out on gnuplot.info website, and they have all the comprehensive documentation as well as demos. Gnuplot has been under active development since back in 1986, and they have very nice demos over here. You can check. Takes a while to load the page somehow. Yeah, here we are. And they have nice demos. You can plot basically everything, starting from simple plots to 3D plots. But let's get back to our SDK. Let's go to the Linux terminal, and I'm already in my working directory. And let's check what we have here. We have the code for the logger.c. And we actually also have a separate program, plot3d, for 3D visualization of logged scans. And we have lnmr.h, which is the header for our SDK library. So let's build a logger.c file. We use GCC for that, GCC logger.c -o logger. Come on. Actually we need to specify our library because we're using SDK, of course. And this is important. Then we launch the logger./logger, starting the laser and starting the scans immediately, and you can see live spectra. So now let's collect the data for a while, and then let's try to defocus. So I rotate the probe, as you can see, and the intensity goes down, goes down, goes down. And this specific program is using 300 millisecond acquisition. There are some delays, so it's approximately 1 spectrum per second, and then it's logging the data to CSV and streaming the data to gnuplot, and I just limited the number of scans to 100. Let's collect some data, 80 scans. Let's wait till it's complete. And we see live output in the terminal so as well. 94, 95, 96, 97, 98, 99. Laser off, closed. As you can see, the laser is off now and the device is disconnected. So let's close gnuplot window, and we explore what we got in the folder, and we got an additional file timescan. And let's see what we have inside the timescan, head timescan, and we have the columns, scan index, then we have the Raman, the pixels, Raman shift in wave numbers, and the intensity. Let's check how many lines we have in the file. If we command wc -l timescan, and we have logged 167,601 lines. Okay, so let's work with the plot3D.c, and let's compile it gcc plot3dc plot3d -o plot3d. And in this case, in contrast to what we had before, we don't need to call our libraries, our SDK, because it's just a helper to visualize. Okay, it's compiled. Then we do plot3D, and we open timescan with it. Actually, it is in the current folder, so it should be /. And as you can see, what we had in the beginning, we had, so it's 3D plot. Intensity is the vertical axis, Raman shift is over here, and scan index. And in the beginning, I was measuring polystyrene, then I defocused it, and the intensity was very low. And in addition to 3D plotting, I have color coding of intensity. I think it looks really great with gnuplot engine. So let's explore the code, and let's see what we have here. And we use VI editor. We open logger.c, and let's expand the window. And as you can see in the what we have in the include section, it is using standard libraries std of C stdio, stdlib, uni-std, time module, time.h, and we also export our header. We use our header lnmr.h. We include it. Then there are constants, numscan 100, meaning we do 100 scans. This function check is to check basically the status of LNMR module. Then there is function capture plot log, which is capturing the data, and then will be which eventually would be logged. So let me check. It goes up to here, capturing and logging the data, and the main loop is over here. So in the beginning of the main loop, we opened the port. As you saw, it was really fast, and it's actually was scanning for all the ports in the computer. Then we set exposure time. Over here, it is set to 300 milliseconds. We set the repetition rate to 1, because in addition to averaging on the computer, it can be averaged inside the firmware on the device, so you can have multiple averages on the device. Camera gain multiplier, we set it to 1. We set laser power to 50 milliwatts. And then what we have, we specify the file name for the, well, actually it generates the file name for the time, for the log, for the CSV log with the timestamp. Over here you can see timestamp in the name. Opening this file for writing, some processing of possible errors, if there are some restrictions on the system. Then over here with popen, we open gnuplot instance. So as you can see, it's a code to another program, and then using this approach you can optimize your workflows and construct your system based on multiple different tools, such as, for example, in this case, gnuplot for visualization. Then sending commands to gnuplot, setting up the axis, Raman shift horizontal axis, intensity vertical axis, set the grid, and then you can actually format the plot using the manual, the information from the gnuplot documentation and website, and then you can make it appearing really nice and the way you want for your workflow. Then next step is to turn the laser on. Output to the terminal, the loop to do scans, and as you can see I set an additional delay here, so everything can be working much faster if you decrease this delay. And in the end we switch the laser off, print a message, close gnuplot, close CSV output, clean up, and as usual in C, return 0. We quit this and let's explore the plot 3D. Sorry, it's the binary compiled. Quit plot3d.c, and it's actually very small program, just calls to gnuplot, and as you can see over here we open gnuplot instance and then send the commands to plot from the file name, which is applied as an argument to the shell command. I think this demo was pretty straightforward, and thank you for your attention. And with this video we covered another part of our SDK, which was a C SDK under Linux. In previous videos it was Python for both Windows and Linux. And then upcoming video would be C in Windows. With this I would like to thank you again, and please subscribe to our channel on YouTube, watch our videos, and if you would like to acquire our SDK, please contact us. Bye.